Hey, this is Steven from Legit Tech Tutorials and the Green Engineers, and welcome back to the WaterJet cutting machine, DIY WaterJet. So we're a little short on information today. We are working, so basically the guys at the place, what was it, something Hawk? Stand by. Riverhawk. So the guys at Riverhawk are talking to me about the this hosing. So I go ahead and show you here. Let me see. So let's go ahead and show this. So here's basically what I found out here. So here's basically the connection on how this works. So there are four. This is for the high pressure tubing. There are a couple different spots on the high pressure tubing that you use. I believe there is three. Well, four counting what you're going to screw it into. So there is a male-female connection, obviously, outer and inner thread. The inner thread in this case is on the pump has an inner thread, and also the cutting head has an inner thread. So those both are inner threads. So basically what we have is you have a 1/4 inch tube, which is saying here, with a 9/16 18 UNF, so that's fine thread. And again, we have a 7/8, so basically they don't have a 7/8 available. So pretty much what happens is they so we're going to have to use an adapter, which is cool. So basically there's an adapter that's going to come off the top of the cutting head and go into there. But remember that because we are doing a manifold on the pump side, we could use whatever they prefer for the fitting. So that is pretty good on our part. So pretty much there's three parts here: the tubing, the gland nut, which is here, right? And then this collar. And basically what I'm thinking that it is it's basically just some sort of clamps down like a collet. So it goes up on this thing and then it clamps around here or something, or seals up around this, and then the only way out is it can't get out through these screws. So, and you can see here that basically this collar is in there, and so the only way out is through. And basically this collar threads on. The collar's threaded here. So and this specific hosing, which I'm going to show you here, is rated for 40K. PSI, I do not yet know the price, so we're going to find out probably tomorrow. So here, 3-piece assembly, gland nut collar, and a 1/4 inch tube or a 1/4 inch hose end. So it's tube or hose. In this case, I have a hose. Slide the gland nut over the 1/4 inch tube or the 1/4 inch hose end. So you just slide this over, and then this gland nut's what takes up the slack. So this guy has a big enough hole where you can just slide it over. The 1/4 inch tube or 1/4 inch hose end, turn the collar counterclockwise left hand thread onto the tube or hose end. The collar should be placed 1/8 of an inch from the tip of the cone. It may be necessary to adjust this collar with a set of vice grip pliers. So basically you move it in until it's 1/8 of an inch from the tip here, which it looks like you could just barely see the end of the thread. So I think it's basically up to the end of the thread. So you use your calipers, you measure up, make sure it's 1/8 of an inch from the end, and then maybe blah 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 blah. Do not strip the threads off of the tube because then you're screwed. Slide the gland nut down with blah blah blah. Stop from rotating. Turn the gland nut clockwise right hand thread and torque the gland nut down to 25 foot-pounds. So I'm gonna have to figure out how to do that, because you can't use a socket, right? Because the socket won't fit over here. So basically, it has to be like a wrench. So maybe I could figure out how to torque that down at 25 foot-pounds. Make sure all parts are clean and free from debris. Blah blah blah. Insert the quarter-inch tube, quarter-inch ends in tensioner or hydraulic pump. While firmly holding the tube or hose end to stop it from rotating, turn the gland nut clockwise. Right-hand thread and torque the gland nut down 25. So that's one page out of 4. And so here is basically the adapter. I do kind of like this because that means that our tube doesn't have to make a full rotation down. So basically this is going to go in. So the 7/8 14 goes into our what is it called? It goes into our cutting head, which is a 7/8 14. So that goes in cutting head, and then this is a external thread, and the head has a internal thread. So this external thread goes to its internal thread. Then you have to then basically their piece goes into this socket here. And so we have multiple pieces here. I believe these are both the same. So I'm curious how much this is going to cost, because pretty much we have to have this to go to it. But I do like that it does have this 90 here, but here it's saying it's almost 9 inches long. So that's already really long. I wonder if I could get this guy shorter. See if we can make this like an inch, or basically as short as we could possibly get it to fit. Oh, I guess this is, so this probably swivels here. There's got to be a swivel somewhere. Quarter to quarter elbow, which is this. I do like this because, again, this goes out one way and then goes down to the pump. And then maybe even that's a good idea to have at the pump where these tubes are facing upwards, and then they basically do that. So maybe I could also get some 1/4 inch tube from these guys, and then I don't have to weld. So basically I'll have I'll just make an aluminum block and then drill left and right side, and then drill 2 holes and tap them with this 9/16/18. And then basically you run the tap in there, tap it, and then we use those same collars to thread into some sort of elbow like this. So basically, or what we could do, actually a better idea, is to have them on opposing sides like you see here. So have one go on this side, one go on this side. So drill through here and then drill down and into those 2 pieces. And then straight up comes the hose out of that piece, and then have something strain relief to hold the hose up, so the hose isn't holding so these 2 pieces of the quarter inch tubing is not holding this thing up. So hold this thing up and then bolt the thing down. So that way I could do all the machining. I don't have to weld stainless or anything like that. I just have an aluminum block here. So have one guy go here, one guy go here, and then this is where the end of the hose attaches and goes up to this part. So it's a 9/16/18 on both sides, and I do like that idea. So I will talk to Tim tomorrow about that. I don't know if you can see that concept. Maybe we'll go in here. And also, one of the things I want to do in this video is design this manifold, which now will help me do machine once, and I just need to drill 2 holes and 3 holes into a aluminum block, and then tap 3 sides, and then I'm done. I don't have to do any sort of crazy cutting and welding and making sure that there's no leaks or anything like that. Really good. So 2 swivels, that's nice. Again, this design is going to be rough, as we don't know what it's going to look like. So here is okay, so this is a shaft end fitting. So here is a port, and here it goes into our thing. So basically what happens is that the ends are swivels. So pretty much you use this to twist it in, because this is just outside thread. So basically you use this to twist it in. I do like this one better. It's short, but it does not have that 90. Again, I can make a 90. Not a big deal. But But then, yeah, getting it to line up exactly. Basically has to be a swivel. I mean, same deal as the other one. Getting that 90 to line up the right direction, that's going to be an issue. Because basically the head, you can only have the head one way or rotated 180 degrees, and that's it. Also, another thing I totally forgot about is we have to make the hopper for the sand, for the garnet. So we're going to need some clearance for that as well. But that could be off to the side or behind the milling machine table. Because again, the thing is like 2.5 inches deep. So it could be like a big pillar canister, like 2.5 inches wide and really, really, really tall. Okay, so I do like this. This one's smaller, so I do like this one. So that's why he said that there were multiple. So I do like this one, but it's too tall. So if we could have this with this. Oh, this is a swivel. So we could get this to be exactly what we need here. But this is the issue here, is I think that this is basically... So maybe I could even ask these guys to make one for me, to make that manifold. I think that's probably the best bet. Because it looks like they have a small taper here. I'm wondering if that's how it seals. So, yeah. So now I'm kind of worried about when I screw this side into the pump. I'm not exactly sure what type of little taper thing it has. So I'll ask them tomorrow about how this seals in the morning, and see how that goes. And high pressure hazard. Oh, and also as you see here, we have a, what was it? This is a 40,000 psi rating. I believe this is still the same. Obviously, it's rotated. But I do like this one because it's shorter, 3 inches. 3 inches is not that long. Obviously, it's sticking on top of the head, and the head already is pretty long, especially fitting it on this gantry here. But this gantry is extremely stiff, so I'm not too worried about that. Anyways, so we'll probably go with this one, and so that is, this one's 200 to 075, 200. So it's different. So this is just the hosing here. So high pressure hose, length 10 feet, color blue, pressure rating 40,000, 40.5 K, in fitting, male 9/16, 18 TPI. So threads per inch, both ends. Permanent label required on hose, stating pressure rating. Roger that. Here is the parts list. We added color blue. Okay, or this is notes. Notes. 49 KSI, hydraulic hose. Cool. And that is it. So, basically what we're going to do now, let's go ahead and go in and design this this thing. And again, we're going to have to give them more to go on than this, but I could estimate what it is. So let's see. So let's go back here, let's scroll back out, and let's look at oops. Okay. Okay, so I think this is about 6 inches here. This thing is big. I'm going to say it's about 8 inches from port to port. Maybe 9 inches. Let's say with 9 inches right now. So I think it's 9 inches port to port. And again, we're going to need 2 sets of this. But one side is going to be low pressure. We could just have... That one I could just make a piece of aluminum something. It doesn't... And we just put Kapton tape... That's not Kapton. It's Teflon tape around it and just screw in a hose, right? And have it suck out of a tank or whatever, or have a tank, suck it out of this other tank, right? and then push it in here and push it through and have a whole bunch of filters and stuff. So basically what we have is we're going to create a line diagram. So let's say here we have the rectangle, and then this is going to be, let's just do a line. So 6 inches this, 3 inches this, or I'm going to say it's 8 inches. Okay, so 8 inches by 8 inches. And then I'm going to say that this is, yeah, so I think that was both sides are like that. So 7/8. Anyways, let's just say that it's an inch. One inch. And this, and this are construction lines. Cool. And then basically what happens is the tubing comes out of this guy. So let's say that it's 1/4 inch tubing. Come on, line, don't glitch out on me now. Let's just have it go up a little bit, just so we're not going over the same line every time. 125. Wait, 125. By 0.125. Oops. And then basically it comes out here about, let's say, 1/2 inch. Actually, we're just going to do a line and do a profile. Not how I'm doing it here. So let's just say that this is 1/2 inch, 0.5. Actually, well, it depends. Depends on, let's do this. Duplicate, I think that was that one, yeah. And then inbox. Let's open up his. Okay. So basically, I just have the exact dimensions. Oh, 7/8 14, so it's about 1.040 clearance. So this is going to have to be like 1.5 or so. Or 1 1/4, 1.25. Right? No, well that's what's popping out, so pretty much that has to go in, and so that's popping out. So over here is the 1.04 or whatever. 1.040. Okay, so that is what's going in there. And then this is, let's say, 1 inch off of that. And then we're gonna take a arc, 3-point, and maybe even 1/2 inch here. Let's put a bend radius of 1/2 inch. awesome what they recommend. So let's do that, and then let's see, do they have a more... Oops. So basically, if I'm looking, oh my god. So basically, if I'm looking at this right, well, basically it goes like that, and then let's do the same thing here. Like 5. Okay, and then bend radius, arc, 3-point arc, bend radius, 0.5. Whoa, what happened here? This is not the right type of arc. What? Okay, let's just do mirror plane. All right. Then base. Ooh. Reset default layout. Then we need to go to the front, and we need to create a circle. And then we need to create, after we escape this, then we need to create a circle here. Uh-oh. Okay, then we're going to create sweep, profile, path. And let's bring the two sketches back up. Sweep, profile, path. Okay. Then goes into this body. So let's just show this like this again, not with no cross section, but it pretty much looks exactly like it. Just create another section. And let's project both of these. Project. Cool. And then let's draw a line down about 1/4 of an inch or 1/8 of an inch. And this is going to be about there. Like that. And then symmetrical about 3/8, I think. 3/8 is not enough because 1/4 inch. It's 1.25, that's 60. So even 1/2 inch is okay. So let's do here. Let's do symmetrical 0.25. So it should be 1/2 inch. Ooh. But then in actuality, this is actually supposed to be 1.25. And then this is supposed to be tall. So it's actually not going to be symmetric. It's going to be two-sided. This down is going to be 0.25. And this up is going to be like 1/2 inch. Oh. Right. It doesn't really matter. Okay. And so that's basically what I'm talking about with the manifold. These two come out, it goes to this piece. Same deal on the other side, but the other side obviously could use way smaller fittings. Just regular 7/8, probably a 7/8. What is that, flare? Brass flare fittings. Let me show you guys that. 7/8. Oh, but it was it 7/8? M14. So pretty much what we could do is we could do flare fitting, but here this one's a male. Really, you need a female. So you use a flare, I think it's called a barb. Yeah. Or something like this, and you just screw it on there. And you just use a thing and, attach it on there. M14 by 2. I think it's... 14 by 1.5. But yeah, super simple. I mean, because again, it's not a water hose, it just attaches the tank. So we attach it to the tank, and we have one of these also attached to the tank. It's not really high. I mean, so that's another thing with the pressure of the water. So it's going to boost our pressure a little bit because all that water is sitting on top, right? So we have all the pressure of that water sitting on top, and we pump it inside and dump it on, all the stuff in there. So that's pretty good. So yeah, basically it's in here. So that's pretty much what we're looking for. So let's go in here and let's save this. Hide all the sketches, and let's save this. We're going to call this high pressure manifold. And then let's do one more, which is basically going to be this high pressure manifold again. So let's see. 1 inch. 1 inch by 3/4. So 0.75 by 1. And then it is 0.5. And then basically what we're going to do is just go here, 1/8 of an inch from the edge, 0.125. I mean, he'll get the idea, you know. Even though it says 0.25, in actuality it's whatever size. Oh, well. Yeah, I could just have it go all the way through. And there you go. So now if you inspect section analysis and we say, hey, I want, or basically construct mid plane between here and here. I want in section analysis this plane, bam. So that's basically what it'll look like on the inside. But how they have it, where it's got the, the little fitting things on it, like this, right? So it's got the little thing there, and if he wants a small little hole, he could have a small little hole, doesn't really matter. So basically like that, and then it has another one from this side, pretty much. So I like that idea for a manifold, and just use the rigid hosing. Doesn't need to be anything super crazy. And then I'll build something down here to hold this thing up, basically on the floor. Hold it up, and so it comes in and it goes up. It's basically these two water jets are going to hit each other, so I might need to ask him what he thinks about that. Might even be better to do some sort of angle in so it goes up or something. So we'll see what he says. Alright, so this has been Steven from Legit Tech Tutorials and Green Engineers. I'd like to thank you guys for watching. If you like this video, please subscribe for more videos like it, and I'll see you in the next video. Take it easy. Peace.